YouTube, in this video we're going to concern ourselves with maximum and minimum values of quadratic functions essentially. And so in our last couple of videos we've explored quadratic functions and their graphs, and we say that these are these bowl-like or U-like graphs that we see here. And one thing we want to point out in this video is basically if you have some equation here, we'll say it's in standard form, f of x equals ax squared plus bx plus c. If a is positive, then we have a graph that opens upward. And if a is negative, then we have a graph that opens downward, of course. What we want to point out here are minimum and maximum values. So when we talk about the minimum value of this graph, we would say that if a opens upward, then this parabola has a minimum value. It has no maximum. And that's important to recognize here that these arrows up here mean that it's never going to stop increasing. So we have a minimum value that occurs right here. We have a min. And if we have a parabola that opens downward, then this graph has certainly a maximum value. And when we talk about max and min values, we're talking about y values. Okay. Interesting thing is we may ask the question, well, where does the max or where do the max and min occur? But the y value really is the maximum value or the minimum value of that function. So that's what this says here. It says if a is negative, the parabola opens downward and the vertex is the highest point. And if a is positive, the parabola opens upward and the vertex is the lowest point. And you're going to have to kind of picture that in your heads a little bit here. But the nice thing about it is we say the x-coordinate of the vertex, remember, is negative b over 2a. And also, we know that the y value of the vertex would have to be what we get when we plug that into the function here. So a couple things that I want to say about this, at least if your function's in standard form, we would say that this is the location of the max or the min. You got to understand I'm just writing here because I have room. This right here, though, is the value of the max or the min, which is an important distinguishing factor between those two things. So minimum and maximum quadratic functions, basically considering the quadratic function given in standard form here, we say if a is positive, then it opens upward and therefore it's got a lowest point, and that lowest point occurs at x equals here, and the minimum value is what I get when I plug it into my function. And likewise, if you open downward, then you must have a highest point if you're a parabola. It must occur at the x value of that vertex, and also the y value of the vertex here would be its maximum value. It says in each case the value of x gives a location of the minimum or maximum value. We say the value of y, that gives the minimum value or the maximum value. So what we're going to do is we're just going to kind of play around with this idea here in these next couple of examples. So this first one here, take a look at it. It says, repeat parts A through C on example 4 using the quadratic function. Bleh. So we have all of this right here. F of x equals this. We would say that I recognize already that this is something that opens upward. Just saying. Let's read the questions now. It says, determine without graphing whether the function has a minimum value or maximum value. Well, hey guys, the first thing we just recognized is this opens upward. So in terms of does it have a min or a max, it has a minimum value. I should put a lowercase m on that just because it has a minimum value. It is so small. We'd say minimum with a lowercase m. Minimum value. And I'm going to say because a is greater than 0, it opens upward, okay? Next, we say find the minimum or maximum value and determine where it occurs. Okay, well here's the deal. When it says where it occurs, it's saying here's the x value that it happened at. And in terms of find the min or the max value here, which we have a minimum value, that's going to be what we get when we plug that value into our function, okay? So let's start with this. We'd say the axis of symmetry of our parabola, which is really what it is that we're finding here, is the x value of our vertex. We say x equals negative b over 2a. And we would say, well, that negative b over 2a value, we would say occurs in our b value here is negative 16. And our a value is 4. We end up with this. We get a positive 16 over 8. We get 2. And you know what? Now that I think about it, really I don't need the axis of symmetry. I'm just out of habit. I find this all the time first, and I just know that this is the x value of the vertex. But really what we wanted to find was this. We would say that for part B, if I list my answer down here, we would say that our minimum value of blank occurs at x equals 2. And so what we found is the location of where this happens. Now we actually know that. We would say, well, that our minimum value, really what we found here is that our x value of the vertex is 2. Now what we want to go do is plug in 2 into our function and see where this minimum occurs. Okay, so we would say, well, this minimum would occur at where I would get when I plug in 2 into the function. So we need to go find f of 2 now, which is really, it's not my favorite thing to do, I'll admit. But it's not that bad. So I'm going to go ahead and do this here. This is why I haven't graphed it yet, because it's really high up there. We say 4 times 4. This is a negative 32 plus 1,000. So we're going to take our positive 16 and a negative 32, which, hey, 16 is half of 32. So this is the negative other half of that. And we'll add these up. We would say, well, 10 off of this would be 990. Minus 6 more would be 984. So we just discovered that, 984 is the minimum value of this function, and it occurs at x equals 2. So the last thing we want to do here is identify the domain and range. And so here's what I want to point out. At least we should have written this here. We found the axis of symmetry. Shame on me. We need to write the vertex. And the vertex we were able to discover occurs at 2, 984. So I haven't even graphed this, but what I know is this. I know that this is the lowest point on the graph, the minimum value. And I also know that this is the x value at which it occurs. So if I want to find the domain, one thing I can tell you about all quadratic functions is that they're U-like, and they go left to right forever and ever. But the range, as far as the range is concerned, I know that because 984 is the smallest y value that this ever reaches, the odd thing about it is that we'd say that the range here would be 984 all the way up to infinity, just kind of visualizing this here. Okay, so this last example we're going to do here, we're going to still play around with the standard form equation, this long one that you see right here. And we're going to talk about, maximum height of something and where it occurs. So we say an archer's arrow follows a parabolic path. The height of the arrow, f of x, so our height here, we're going to make a little note here. This is our height of our arrow. In feet can be modeled by this equation right here, where x is the arrow's horizontal distance in feet. So we say x is the horizontal distance in feet. Okay. So when we look at this, really what we have is this parabola. I'm looking at this, and I know that this thing opens. Which way does it open? Downward. And we'd say that I've got something that's doing this right here. But essentially what it says is what's the maximum height of the arrow and how far away does this release occur, where we have our horizontal distance down here, and then we have our vertical distance right here, so our height as a function of its horizontal distance. But basically the maximum height, that's going to occur up here, and that's going to be the maximum value of our function, our maximum y value. And then the horizontal distance would just be our x value at the vertex here. So what we want to do really is find the vertex on this, and the vertex again is at negative b over 2a, and then what we get when we plug that into the function. The only reason I say that here is because it's in standard form, ax squared plus bx plus c form. So let's go ahead and identify a few things here, a, b, and c. I don't think we need all of them, but I think it's a good habit to have this. 0.005, we have 2, and we have 5. I'm going to box these. So we say, what do I need first for my vertex here? Well, we kind of need the axis of symmetry. So we say x equals negative b over 2 times a, where our b value here is positive 2, and our a value is this really, really weird looking number here. Not weird looking, I shouldn't judge. But we would say a negative over negative is a positive, and I could see that, like our 2's, they cross cancel here. I suppose I will. I can't resist the urge. I would say this is a negative 1 over this, but we need to get out a calculator here. And so what I'm going to do is I'm going to hit just a positive 1 divided by a positive 0.005, and it looks like I get 200 here. So we would say that 200, that is the x value at our vertex. I'm going to go put that up here. 200 and f of 200 will be our y values. We say, well, now I need f of 200. So our vertex, I need to write this down here. Our vertex occurs at 200, comma, f of 200. And so we're going to go find this f of 200 now. So this is where we're going to need a calculator. We would say negative 0.005, 200 squared, plus, now I'm going to carry this down here, and I sincerely apologize, 2 times 200 plus 5, all of this expression right here. And I realize something, sadly, I'm going to have to get my graphing calculator out here, which I have no problem with, graphing calculator. It's just that when you open this up on a computer, sorry I'm just talking to you right now, I'm not trying to waste time. You have to adjust the contrast on these stupid things so you can see it better. Okay, so you ready? We have negative 0, 0, 5 there, 0.005 times in parentheses 2 hundo to the power of 2. And then we're going to say plus 2 times 200 plus 5. This is going to make our job a little bit easier. We get 205. So our vertex value is at 200, 205. And what we want to recognize here are a couple of things. We say, what is the maximum height? Well, it does have a maximum height since it opens downward, but we say a max height is actually our y value at our vertex we have is 205, and we're going to label this in feet. And I'm going to write here also, it occurred 200 feet away from the archer. Okay, so we say find the horizontal distance the arrow travels before it hits the ground around to the nearest foot. So when we say where on our diagram here is it at the ground, I would say, well, right here and right here. But what I want you to understand is that those are the x-intercepts. So to answer this question, what we're going to do is we're going to go solve for these x values where our y values are 0. So I'm going to borrow a little bit of space here. Hopefully I'll trap off enough room here to give myself something to write in. But we would say that what we really want to find is when we set this equal to 0, when we set it equal to 0, plus 2x plus 5, what do we get for x values? So the important thing here is that we're actually going to use the quadratic formula. This is something that is not worth trying to factor and just has really kind of exotic values. So we're going to get this, negative b, so negative 2 plus or minus the square root of b squared. So we have 2 squared minus 4 times this really, really fun number here, negative 5 thousandths. And then we'd say times c right there. And this is all over 2 times a. And my favorite part about this problem is that we're just going to use a calculator to do this. So let's work a value here on our graphing calculators. We'll start with what we have on the top. Inside of our radical here, I have 2 squared. We'll do our discriminant first. 2 squared minus 4 times negative 0.005 times 5. Enter. So we get 4.1 as being this value in here. So I'm going to simplify this here. It'll let me here. I think it is. There we go. Negative 2 plus or minus the square root of 4.1. And this is all over now 2 times this. And if I just wanted to check that, I say 2 times a negative 0.005. I'm going to get this, negative 0.01. So negative 0.01. And so now we just want to type all this in. I say, yeah, I just want to type it all in. Well, I say, to be careful about it, let's put everything on top in parentheses. So parenthesis, and I'm going to write negative 2 plus. Now when you hit the square root key, it's going to give you another beginning parenthesis. So we're going to have to put 2 end parentheses on this to trap off the top. We're going to divide everything here by negative 0.01. And so here we go. Hit enter, and we get x equals negative 2.48. So one of our x-intercepts is actually negative. It's approximately negative 2.48. Weird. And when we go back and type all this in again, yes, type it in again, we're actually just going to hit second enter key, and it just types in what you had before. And I'm going to go up and I'm going to change this to a subtraction sign, hit enter again. We get 402.48. So 402.48. And so if you're asking why did we get 2 answers, well, one of our answers kind of occurred before the experiment started. And we say our other x-intercept was 402.48 feet away. So that 402.48, 402.48 comma 0, that's the distance we're looking for here. So rounding to the nearest foot, I would say that that's approximately 402 feet. Okay, so graph the function that models the arrow's parabolic path. I would encourage you to put this into a graphing calculator and go at least 403 feet out on your right, and go up at least, now that you know the maximum value is 205 feet in the air, at least 205 on your y-axis, but see what this graph looks like. Cheers.